Right. Thank you, Litira, for reminding me the recording. And I start the recording, and we are going to continue from the place we have stopped last week. So last week we discussed about two coding methods, right? Which is the BCD and the ASCII, right? So today we are going to go to learn about the other two methods, which is the EBCDIC and the Unicode system, right? So now I think you can remember the coding systems that we learned last week, which is the BCD, which stands for binary coded decimal. And there they have used 4 bits to represent a particular character, right? And then after, they only use that BCD coding system to represent the numbers from 0 to 9, right? And later, with the improvement of the computer, they had this requirement to represent more characters like letters, like the punctuation marks, all kind of things. So 16 or like the 4 bits are not sufficient, because with 4 bits, 16 number of different patterns we can represent, but not more than that. So if you think about the alphabet, the English alphabet, it got 26 letters and has 2 variations like capitals and simples. So altogether, to represent the capital and the simple letters inside a computer, we need 52 different, 26 plus 26. That means 52 different codes, or like 52 different patterns in binary, right? So just 4 bits are not sufficient. The 4 bits පාවිච්චි කරලා අපිට ගන්න පුළුවන් patterns 16යි, like 0000 to the maximum that you can go is 1111. That means 15, from 0 to 15 we can represent, right? So because of that, later they have introduced a coding system called ASCII, American Standard Code for Information Interchange, and it consists of 7 bits, so which has the capability of representing 128 different patterns, so which was sufficient to represent the characters on those days, right? But later, the requirements are getting complex with the computer evolutions, right? So at some point, this 7-bit code was not sufficient to represent these characters in the computer, right? So they have to go for another extension, or like another improvement, that is called EBCDIC, Extended Binary Coded Decimal Interchange Code, EBCDIC. Now this EBCDIC is proposed with 8-bit code, right? Previously the ASCII has 7-bit code. Now this is having 8-bit code. And that means the EBCDIC has the ability to represent 256 characters, or like 256 different patterns using those 8 bits, right? And EBCDIC has this 26 different codes for the capital letters and 26 different codes for the simple letters, right? As it done in the ASCII as well. So the only difference in between ASCII and the EBCDIC is the number of bits. ASCII was 7-bit code and EBCDIC was 8-bit code, right? And story is not going to end from here, people. Now, if you think about today, the character representation of a computer is very big in number, right? Why I'm saying it is big in number, especially now the computer is supporting for many different languages. So many different languages means many different characters, right? If you think about the Sinhala language, we got 56 characters, right? And we have this Alapilla, Papilla, Ispilla, we have all those things. Even those are considered as separate characters. So it needs again, like all together, we may need like 70 to 80 different patterns to represent the Sinhala language. And if you think about the Tamil language, it's another different kind of characters. I don't know how many are there, but I know it is very bigger than the Sinhala alphabet, right? So that requires, again, different number of patterns. And if you think about Chinese, Japanese, and Arabics, and Hindi, and all these languages having different kinds of characters, so they requires different kinds of patterns. So definitely, 256 is not a number which satisfies those combinations, right? 256 will nil. බොහොම සුළු ප්‍රමාණයක් අපිට පෙන්න ගන්න පුළුවන් වෙයි. Like you can use it for the if you think about the keyboard itself has 108 number of keys, right? Somewhere around 108. So from that, at least 100 keys contains characters, right? So keyboard need 100 different characters itself, right? At the hand, we are just discussing the things. We didn't write anything, right? And that is from English. And when you are embedding the Sinhala language into it, again, it comes with another 70 to 80 characters, right? So it will require 180. And if you think about a language like Tamil, I'm pretty sure it goes the characters beyond 100, I think, right? So then it will goes like 280. So then and there, 256 characters are exceeding, or like that requirement is, or the 8 bits are not sufficient. What I'm trying to say is EBCDIC fails when the number of languages are increasing inside the computer, right? So to solve this, they have introduced another code system, and it is the one which is using at the present, which is called the Unicode system. And Unicode system has 16 number of bits, right? So the 16 number of bits has the capability of representing 65,536 different characters or different patterns. So it's a huge amount, right? Which is satisfied or like which can satisfy all the requirements inside all the character requirements inside the computer, right? So like I said, these Unicodes are used to represent these kind of Sinhala letters, Tamil letters, English letters. There are special symbols and emojis, right? Different kinds of stuff. And as well as it is used to represent the pictures and all these things. Like characters, it's only the letters, right? It's not only the letters. If you take a picture has many different colors. So each and every different color is going to represent from a particular code, like it represents over here. So that here they have given the color variations of the red, from like red to orange. So each and every color variant has its own different code, right? So if you think about the number of colors that we are going to use, right? In the multimedia lesson, you will learn like sometimes it goes like 2 to the power 32 number of colors, right? So in those cases, Unicode is going to be like more extended to represent those colors, right? And as well as when it comes to the audios and all these things, audio is also represent as bits and bytes. That means in different coding systems. Right, so each and every point of an audio clip has its different type of pattern, which consists of ones and zeros. So likewise, the full idea that you need to hear is, like the big picture that you need to see is, there are many different things to a computer to illustrate, and it needs different number of patterns or the binary numbers to represent those different kinds of things, right? So in that case, Unicode is the one which is doing the purpose, or the serving the purpose for the moment. All right, people, is that clear? Everyone? About the EBCDIC and the Unicodes? Right. Okay, so then let's write some of these, right? So put the heading EBCDIC, this highlighted part, and yeah, you better start writing from here. Yeah, regarding EBCDIC, that is sufficient. Once you are done with it, I'll move to the Unicode part. All right, one is done. How about others? Okay, is there anyone still writing this down?
Excuse me, sir.
Yes, sir.
Sir, can you again explain about this ABCDIC code? Because
Yeah.
it's not clear for me.
Yeah, it's like this, though. Like, can you understand this? EBCDIC is used to represent the characters of the computer, like the letters, like the exclamation, like the punctuation marks, and all these things. Can you recognize that?
Yes, sir.
Right. Okay. So, like, but since the things have been increased, right? So like the examples which is shown here, now they have take the character A. So to represent character A, they use this 8-bit code, which is the EBCDIC code, right? So likewise, it is having the capital English letters, it is having the simple English letters, it is having the punctuation marks and all these things. So for each and every different character, they use this kind of 8-bit code to represent them, right? So the plan was using 8 bits, it has the ability to represent 256 different symbols, right? So likewise, they use those 256 different symbols to represent these characters. So as an example, these capital letters and these simple letters are represented by these codes inside the computer. So once you press the capital A, processor receives this code. So processor understand, okay, it is the A that they are dealing with, right? So if you give simple B, so processor receives this code. So processor can understand, okay, this is the character that they are dealing with. So likewise, for 256 different characters are capable of representing using EBCDIC. Got it, Dua?
Yes, sir. Thank you so much.
Right, okay. Right, so is there anyone? All right, okay. Vimindu, hurry up. Right, so moving forward, we are going to write about the Unicode system. So have the heading and yeah, it's better you write this first, copy this first. And then you can write this. So before you write the second line, it's better you say as an example, Unicode system can be used to represent Sinhala Tamil letters. I'll write it down for you, right? Hold on. Right, as an example, then you move with this. Right, one is done. How about others? Right, so moving forward, let me know if anyone is missing with the writing part. Let me clear the annotation. Right, so, and to your note, you have to copy this line down as well. And there are some more at the, no, regarding the graphics and all these things, you don't need to, and then after the things, right? So first you copy, you add this down, like as a separate paragraph or to the same paragraph, it doesn't matter. Right? Just add this line. This is not like an example. Yeah, it doesn't matter. Like if you take it as a point, it says Unicode system, use unique numbers for each number, text or symbol in any O operating system, right? So it continues the things from here. Okay. Are we done with this? All right. So moving forward, and we really don't need to like go through these examples like picture and graphic data, because we are going to talk about these things in the grade 11 lesson, the multimedia lesson. So I'm not going to make any hassle in this point. But this particular things, these we need to write it down, because this says who maintains the Unicodes, right? And what are the places that the Unicodes are used heavily in these days, right? So Unicodes are like, these are initiated with the International Standard Institute and the Unicode Consortium, and they are maintaining the Unicodes, right? And they are largely used in designing websites and newspapers and all these things, right? So copy that down. Then we can, yeah, we can see to an end to this lesson. So we can walk to the fourth one. Yeah, I got a question. Dihan, oh, Dihan, are you? නෑ නෑ දිහන් අපි ඔය යන එකටම ලියා ගන්න පුතේ මේ දැන් මම highlight කරලා තියෙන එක වෙනම paragraph එකක් විදිහට right under the same topic. Okay, one is done. How about others? Okay, two are done. Is there anyone still writing this? Okay, so now people, we are at the end of the third lesson. So before we end the lesson, yeah, I want you to copy this down. Right. Yeah, I want you to copy this down with the additional column, right? So the additional column will give you maximum number of characters that can be used. I will write it for you. Right, so you may write the paragraph with this column inside it. So this has maximum number of, it's quite big, hold on. Started from the top. Maximum number of characters that can represent. So it's going to be 2 to the power 4, which is equals to 16. This is going to be 2 to the power 7, which equals to 128. This is going to be 2 to the power 8 equals 256. This is going to be 2 to the power 16, which is going to be 65,536. Right, so add that to this table as well. Right, please complete it. Yes, we have to write that. Dihan, that's what I was telling. You have to copy this, copy the chart with my new column, right? No, Dihan, this is something like as the special point code system used in computers, it's like a summarized thing. So like apart from that, the last paragraph that you have written, then after that, you just draw this. That's all, Buddha. Right, two are done. How about others? Is there anyone still writing this? Okay, Dihan, be quick, right? Okay, so that's the end of the num system lesson, right? So now we are going to move to the logic gates lesson, which is the fourth lesson, right? So after we are done with the fourth lesson, we are going to do the Excel practicals, right? Okay, so let's move to this new lesson of ours. So it is called the logic gates, right? And here in this lesson, we are going to talk about the circuit, how the circuits are developed in the computer, and we are just not going to talk about the major part or the massive part of the circuits, but the little components, like the most little component inside the circuit, which we call or which we address as the gates, right? And you know, computer is a device which dealing with ones and zeros, right? That is what we learned in the previous lesson, right? Computer can understand ones and zeros. So here in this lesson, it illustrates how the computer is dealing with ones and zeros. And we know computer is work with ones and zeros, right? So instructions, like we learn about the coding systems. So everything was in binary, like the last four coding system that we learned, the BCD, ASCII, EBCDIC, and Unicode. Everything was representing in ones and zeros, or in simple terms, using bits, right? So now we have to know how these bits are being manipulated or how they are being processed inside the computer. So you know there are input devices to input the data. So the data will be received as ones and zeros to the computer, or literally to the processor. And then the processor and the other components are going to process the data that is received by them. So how this is being processed? What are the components that help them to process, right? So this is what we are going to talk inside this lesson. And in here, we are about to learn about the things like the components that help to process this thing, which we call the gates, and what are the functions of those gates, right? So first of all, let's get to know about the gates and what it does. So this introduction is just introducing you about some practical scenarios, right? Where you can experience, like in a vehicle, if you don't put the seat belts, it will give you some alarm sounds. If you are like open the door while the engine is on, it will alarm you. And in the security systems in a home, like if it penetrate from someone, or like it will like due to a theft kind of a situation, there will be alarm systems that are being worked, right? And you have experience like there are bulbs which respond to the light intensity around the environment. අඳුර වැටෙනකොට bulb එක පත්තු වෙනවා, එළිය වැටෙනකොට bulb එක off වෙනවා. So some kind of things are happening here, right? So they sensing and it is working, right? So most of these things are work under the signals, right? So we are going to talk, so the same scenario goes with the computer. Computer is like sending and receiving the signals from each and every device as the bits, 0, 1s and zeros. So what's happening to these things inside these circuits, right? So to talk about this, first we have to have the idea about logic gates. Now this is, in most of the cases, this is going to be a very new and very fresh things for you all. So I'm going to tell you what are the things inside this computer that we are calling gates, and what are the structure of those, right? All right, please have the heading, people, right? Have the heading, the fourth unit, logic gates with Boolean functions. Then you are going to write the subheading called logic gates, right? So this is going to be the main heading, logic gates with Boolean functions. right, then we don't need to write anything about the introduction. Have the subheading logic gates, and yeah, it's better you copy the very first paragraph onto your textbook. So copy the highlighted part, people. All right. Is there anyone still writing this? And people, I missed a very important line over here. Please copy this as well. I'm very sorry. Central processing unit is made up of a collection of large number of logic gates. Please copy that. It's very important. All right. Is there anyone still writing this? Okay, Dihan, hurry up. Okay, so we are moving forward. Now we are going to learn about these gates. And you can see in this picture, there are some significant words like and, not, or kind of things, right? So let's see how these things are, like what are these words and why these are things called this kind of names, and what are they, like what are the functions that they can do, right? So I'm going to summarize it over here in your whiteboard, right? So regarding the logic gates, people, when we consider the logic gates, first it is divided into two categories, two major categories, right? So if you take logic gates, right, this divides into two major categories. So one is called the basic gates, and the other one is called the combinational gates, right? The basic gates and the combinational gates. Now, first I'm going to talk about the basic gates, right? What are these basic gates? Like when it comes to the advanced level, in A levels, we talk about 4 kinds of basic gates, but in O levels, we are just introducing you 3, right? So these 3 has some nice names, right? Those names are not alien for you, but according to this section, it will be something fresh for you, right? So these gates are called NOT gate, AND gate, and OR gate, right? So the names NOT, AND, and OR. Now, since we are talking about the circuits, as you can remember in your science subject regarding this electrical related lessons, right? They introduce you some kinds of symbols, right? For some resistors, for bulbs and all these things, they have these symbols. So likewise, these 3 gates has their symbols as well, right? So the symbols are going to be something like this. So the NOT gate is going to represent like this. Oh, I'm sorry. අපරකින් ළමයි ස්ක්‍රීන් එකේ දාඩිය තියෙන නිසා එයා ලියවෙන්නේ හරියට. Let me take it out. Okay. Oh, Dihan සිංහල meaning එක තාර්කික පරිපත කියන එක. Oh, what's happened over here? Right. Okay, so the symbol is like this, a triangle and a small circle in front of it. So this is the NOT gate symbol. And the AND gate, you can see AND is end with the capital D word. So you can remember AND gate is something like a letter D, right? And it has two lines at its left and it has one line at its right. So OR gate is something similar with the AND gate, but not much. It is staying as a crescent, right? And it has two lines at its left and one line at its right. Now, these lines, what are these lines are for? Right? So the left-hand line, the left side line is called the inputs. Right? Or we use to give inputs from these lines. And the right-hand line is taking outputs. Right? So likewise, in every gate, the left-hand side lines are called the input lines and the right-hand side line is called the output line. Right, so when it comes to the NOT gate, it is special. It can only have one input line, not less, not more than that, only one. And in all the gates that you are going to learn in your syllabus is having only one output line. In any gate, you can see there is only one output line, right? And according to the nature of these gates, we are indicating using the Boolean variables. Boolean variable means, again, some capital letters of the English alphabet to represent what happens to the inputs when it is traveled through these gates. Gate ඇතුලෙන් ගිහිලාම input එකට මොකද වෙන්නේ කියලා represent කරන්න අපි English letters පාවිච්චි කරනවා. Right? So as an example, if I take, if A is input into the NOT gate, I represent the output is going to be A bar, or I can represent it as A dash. I'll tell you what is this A bar and A dash, right? So we represent it like this. We say the process that this NOT gate is doing as Boolean invert. Right? A Boolean invert. I'll tell you what it is. Like, තව ටිකකින් ඔයගලන්ට clear වෙයි මොකක්ද මේ invert කියන්නේ කියලා. Right? And here in the AND gate, if I give A to one side and B to another side, to make it a very common scenario, our output is going to be A dot B. Now this is called a Boolean multiplication.
So we have lower table.
Right? Boolean multiplication. And when it comes to the OR gate, if you take A and B is input over here, sorry, the output is going to be A plus B. And that is called a Boolean addition. Boolean addition. And I know that you are familiar with what is multiplication, what is addition, maybe not with the inversion, like the inverted part. right? So I'll explain now what is actually happens over here, right? Now, to explain this, I'm going to use a particular table which we are going to name as truth table, right? Truth table. Satyadawagu kila api sinhalin kiyනවා, truth table. So this truth table is going to elaborate what is actually going on with a particular gate. And even though we have represent these inputs in letters and outputs in letters, we call those things Boolean variables, right? So even though we represent the gates operation with Boolean variables, truth table will illustrate you what are the values that these Boolean variables can take, right? So it's like this. Now, if you think about the NOT gate, you can see there is an input called A, right? So, you know, computer can have the inputs as ones and zeros. So since we have one single line at the left side of the NOT gate, we can say sometimes A can receive a 0. And in some another time, A can receive a 1. Right? Since the computer receiving ones and zeros, for a given time, A can receive a 0 or A can receive a 1. Now, when it travels through the NOT gate, it outputs A bar, right? Or A dash, we say. So what is represented by this A bar or A dash is the complemented value or the inverted value of the input. Inverted value means the right opposite. So what is the opposite of the 0? It's 1. What is the opposite of the 1? It is 0. So simple as that. If 0 inputs, NOT gate will output 1. And if 1 input, NOT gate will output 0. Right? So this side indicates input and this side indicates the output. People, are you clear with this? What's going on with the NOT gate? Come again, Puta. I can't hear you clearly.
So can you tell about the truth table again?
Truth table, right? Okay. So I'm talking about this particular A Puta. Me metana input kala diyena A එක ගැන මම කියන්නේ, right?
Okay.
So that A going to become A bar or A dash as the output. So NOT gate is the one which modifies or which process the input into an output, right? So how it is being processed, NOT gate එකේ විදිහ තමයි, whatever it is being received as an input will be inverted or in simple terms will be flipped into its opposite. 0 ආවොත් 1 කියලා output කරනවා. Process කරලා 1 කියලා output කරනවා. 1 ආවොත් NOT gate එකෙන් process කරලා 0 කියලා output කරනවා. Is that clear?
Yes.
Right, great. So this is what we call the truth table.
It is for the NOT gate, no?
Puta, come again.
So it is for the NOT gate.
This is for the NOT gate. Yes, this is only for the NOT gate. Right? hold on, I'll take this part little bit right words, otherwise things will get mixed up a little bit. Hold on. Right, okay. Right. So this is regarding the NOT gate. So in the similar manner, we are going to discuss this regarding the AND gate as well. So, but when it comes to the AND gate, it has some differences. The major difference is it is having two inputs. And the output indicate as A dot B. And previously I told you it is doing Boolean multiplication. Dihan, yeah, wait, Pudala, I will tell you when to write, right? So AND gate is doing a Boolean multiplication. Now, Boolean multiplication in your level, in your syllabus, Boolean multiplication equals to the general multiplication. There are some differences when it comes to the advanced part, but in your level, Boolean multiplication is very much similar to the normal multiplication. Now let's consider about A and B, the inputs. What are the values that the A and B can take? When the A is received with a 0, B can also receive with a 0 at the same time, because they are having two lines. When A is having a 0, at the same moment, the B can have a 0. Or sometimes when A is having a 0, B can have a 1, another different scenario. In the same way, when A is having a 1, B can have a 0. And the last combination, when A is having a 1, B can have a 1 as well. So 4 different situations. Both can have zeros at one moment. A can have a 0 and B can have a 1. Or A can have a 1 and B can have a 0. Or both may have 1s. So these are 4 different scenarios. So what's happened in these 4 different scenarios? When the A and B lines are flows through an AND gate, right? The inputs will be multiplied. So it's very easy, right? 0 into 0 will produce you a 0. Simple multiplication. 0 into 1 produce you a 0 again. 1 into 0 produce you a 0 again. 1 into 1 will produce you a 1. Right? So can you see the speciality of this truth table? When at least either of 1 are going to be a 0, the output is going to be a 0. When both the inputs are 1, then only you can receive a 1. Yes, people, are you getting this? Can I have the confirmation? Right, great. So these are inputs and this is the output. Right? So very similarly, we are going to discuss about the OR gate. So you can see I have written Boolean addition regarding the OR gate. So since OR gate is having 2 input lines again, and the output is going to represent A plus B, Boolean addition. So now we know the combinations are going to be very same, right? 0, 0, 0, 1, 1, 0, and 1, 1. So the output is A plus B. So when the inputs flows through the OR gate, it takes the input and do the Boolean addition. Now this Boolean addition is also like almost same to the normal addition, but it differs in one particular place. In first three patterns, 0 plus 0 will give you a 0, like it happens in the normal mathematics. 0 plus 1 will give you a 1. Again, same as mathematics. 1 plus 0, again going to give you a 1. Again, the same mathematics. 1 plus 1 in the mathematics, according to the addition of the mathematics, we say it's 2. But in Boolean algebraic mathematics, or in the Boolean addition, 1 plus 1 is going to produce you a 1. Right? So that is the place. Right? So that is the place that we are using the Boolean addition, or like that differs the Boolean addition from the normal addition. Dihan, ඔයාගේ ටෙක්ස්ට් බුක් එකේම පොඩ්ඩක් පිටු කීපයක් පහලට ගියාම ඔයාගේ උත්තරේට ප්‍රශ්නෙට උත්තරේ හම්බ වෙනවා. අපි ICs කියලා ජාතියක ඉගෙන ගත්තානේ integrated circuits කියලා. So inside the integrated circuits you can find the logic gates. Right? අපි කතා කරනවා පුතේ ඒක ගැන ඉස්සරහට. Right? අපි settle කරගමු එතකොට. Right, so these are the inputs and this is the output. All right, people, now it's the time for you to copy this down. And when you are copying it down, it doesn't matter. So you copy it down the very same way. People, I want you to clarify why 1 plus 1 is 1 over here. The reason is in Boolean algebra, we are working with the Boolean values. Now, Boolean values has these two values which indicates 1 and 0. 1 is indicate as true, 0 is indicate as 0. I'm sorry, 0 is indicate as false. 1 is true, 0 is false. So that is why 1 plus 1 is equals to 1. That means a truth is added with another truth will produce a truth again. Right? So it's better you indicate it at the bottom line. So in Boolean algebra, 1 is equals to true, 0 is equals to false. Right? Dihan, you can download the textbook from the publication site. I'll show you how to do that. Okay, so people, it's better you copy this down. I'll keep the entire diagram like this so you can focus or you can maximize it, zoom it in your device, right? So please, කලබල නැතුව copy කරගන්න. Yes,
So we
Puta.
have copied whole thing.
Yes, the whole thing. Yes, the entire thing. Take your time, right? කලබල නැතුව කරගන්න. right. No problem. No problem, Dihan. ඕගලන්ට මේක එකක ලියන්න බැරි නම් මම කැමති මේක එක පිටුවක ලියා ගන්න පුළුවන් නම් මට හිතෙනවා ලියා ගන්න පුළුවන් කියලා පොඩි පොතක වුණා. If it is a CR book, it's not going to be a problem anymore. But එකක ලියා ගත්තනම් හොඳයි කියලා හිතෙනවා මට. Right? මොකද අර ඒ truth table එකයි gate එකයි පුතා එක ළඟ තියෙන එක වටිනවා. ඒකට පැහැදිලි ඕගලන්ට එක බලනකොට මේකයි සිද්ධ වෙන්නේ කියලා. Right? So try to have it in a one page if it really cannot, if you can't really do it. If it is a small book, take 2 pages at the same level. කියන්නේ එක තැන තියෙන ඉස්සරහ පැත්ත පිටිපස්සයි පාවිච්චි කරන්නේ නැතුව pages දෙකක් නේද? මේ විදිහට පොතේ පාවිච්චි කරන්න. මේ මුළු කොටසම පාවිච්චි කරන්න පොඩි පොතක්. Right? Try to go like that. So it will be again ඕගලන්ට ඊට පස්සේ ඕක විතරයි බලන්න තියෙන්නේ. It's like a summarized thing. Just look into it and just understand what it is. So one is done. How about others? All right. So is there anyone still writing this?
So can you give a 1 minute?
Yeah, sure. Right. Okay. So people, since it is 7:13, I am going to end the session like after by drawing this. So like people who are still drawing it, so go on. Others can leave. Right. We are going to talk about the combinational gates by next week. Right. So we are meeting for the same time, 5:45. Right. So be safe, people. So people who have done with this, you can leave. Right. So good night. And I'm going to stay until every one of you are leaving the session. Right. So others can complete your work. The people who have complete the work, you can leave, right? So thank you very much and have a very good night, people. Right, okay, people. Thank you very much. Good night.